All right, so we just saw in the last video how to place a daughter volume in our world volume, and we saw that both volumes are shown as white wireframes because by default Geant4 shows volumes as white wireframes. So I'll just quickly show how to add some color to these volumes. But before this, I just want to quickly point out something I forgot to mention in the last video. So as you may have noticed, when we were placing our fizz box physical volume, that the arguments that we put into the G4 PV placement function, so these arguments here, were a bit different from the inputs that we put into the world volume. So for instance, the logical world, for when we place the fizz box, you notice that after the name that we gave it, that we gave it the logical world, and this was representing the mother. And whereas with the mother volume, we just had no argument, and instead, well, we just had a 0, and this was because it's the world volume itself. So this is just because this volume is the world volume, so naturally it can't have a mother volume since it is the very top volume. And also we didn't have a overlap thing, overlap detection argument, because again it's the world volume, so it can't be it shouldn't be overlapping with any volumes that are already placed, because it should be the first volume it places. And remember that I mentioned that there's various different functions, different varieties of this same function. So this G4 PV placement, it can take in multiple combinations of arguments, and this will be depending on how you want to define your physical volume. So I'll just quickly illustrate this. So if you just Google the G4 PV placement, or you could even just look it up in the software directory, look at the source code, then you can see these different combinations that this function allows. So this is called overloading, and it allows different combinations. So for instance, if instead what we did was we defined this placement in terms of its logical mother, so in case the logical world, but we could also use a different function where it's placed with respect to a specific physical volume. So if we had multiple mother volumes, then it wouldn't place in every volume, it would just place in a specific physical volume. But I just wanted to quickly point that out of the multiple functions just before we go in the visualization. So if we just go down with our visualization, see we've got example already of the G4 viz attributes, which assigns visual attributes to logical volumes. And we can also, if we just wanted to go to the Geant4 documentation, we can just go to the visualization section and look up all the visualization functions. So if we want to apply some color to our geometry, we can let's just copy this whole function here. And this was originally just for a world volume, but let's just rename this as box at for box attributes. And if we just place all these with box at, so the first argument we're giving it is its color. So in Geant4, these are just set up as RGB, so red, green, blue. So we can give it different weightings of colors. So if we just wanted a complete red box, we could just go red 0, 0, and we just change this from logical world and instead give that logical box. So what we do, we create a visual attributes variable, so in this case called box attribute, and then we give it a color, and then another argument we give is the visibility. So in this case we're saying true, so we want to see our volume when we visualize it. Then the next argument is set force wireframe, so that just means visualize the volume as wireframe. And then finally we give it we tell it which logical volume we want to apply this attribute to. So in this case we're applying it to the logical box. So we've saved that, so let's just exit our visualization. So currently we've got our white fizz box in our white world. So if we just close that, recompile, and that compiled okay. So let's just run it interactive mode. And you can now see that our box is now red. And if we rotate it here, it's all red. Good, good, good. And if, let's say, so remember this is red, green, blue. So if you wanted to give it a weighting of 0.2 of green, you could do that. So if you recompile that, you would have a slightly different red. So if you just visualize it again, so nothing exciting, just a slightly different red. But another thing you can do is, instead of having a wireframe attribute, you can set it as solid. So if we just get rid of set force wireframe, instead have set force solid. And if we compile that, compiles okay, and let's visualize again. So now see we've got this solid cube, and I'll just put back to wireframe convenience. And so this attribute, this can be applied to as many logical volumes as you want. So if wanted, we could just also apply it to the logical world. And so if I compile that, see now we've got our world showing up as a red wireframe, as well as our fizzbox cube also showing up as a red wireframe. So just gonna get rid of that logical world box since I want to keep it as white. But one thing to be aware of is if you try to visualize a volume which has curves, in particular like a cylinder or a sphere, then you've got an issue with, if it's a wireframe, then this will just be at best one line. So what we want to do is, well, let's just show you. So let's say we want to place a sphere. So if we go to a geometry documentation online, and if we go to constructed solid CSGs, so we can just see a list of all these different volumes. So if we go to scroll down a bit, we see an argument for an orb. it should be, so yep, so G4 orb, and we've also got a G4 sphere, which is just a general sphere, whereas orb is a solid sphere. So the arguments it takes in is just the radius, whereas if you want to do a semi-sphere or something, you could give it an angle here. So if you're interested in different shapes, just look up documentation for CSGs. So let's just place a solid. So we'll go G4 orb. So if we want to, so let's go back to our detector construction. So if we want to use a G4 orb, we have to include it. So I'll just make sure I haven't already hidden it in here. So there's no orb. Oh, what's that showing me? Oh no, orb builder. So we've got no orbs. We haven't included the orb class already. So let's just separate the box and the orb to split up the different volume shapes. So we'll include the G4 orb header file / class. So let's just place our orb here. So I'll make a comment. Place orb. So if we go online, we see the name's G4 orb. So if we just go G4 orb, and like all the other, just like the boxes, put an asterisk after, and let's call it water orb, and use the same old style we did for the G4 box. So we'll give it a name. Let's give it water orb as the name, and remember this the function here, it tells us what to put into it. So here it expects just the radius. So in this case, let's make this equal to the box, and this is total length. So let's just halve it, and then we want to turn this into a logical volume. So logical volume, and let's call it logical orb, and new G4 logical volume, and let's give it the import of water orb for the solid. Sorry, water orb. And next argument is the material type. So let's just keep it as water, and then give it a name. So logical water orb, and again 0, 0, 0. Semicolon that, then place our G4 physical volume, and let's go phys orb, and G4 PV placement, and I feel like I spelled something wrong there, but the compiler will tell me shortly. Rotation matrix 0, since we don't want to rotate it, and G4 3 vector, and in this case I'm going to place it, I'm going to make this orb be placed in the center of our fizz box. So I'm just going to put 0, 0, and I will then give it the logical volume, which we'll be placing. So log orb, then the name of it, so let's just call it fizz orb, and then we want to give it the logical volume that it's placed in. So if you're copying and pasting from your fizz box which you place, you'll notice that it's got logical world there, but in our case we want to place it in we want to place in the fizz box. So in this case we have to change the mother volume into the what did we call it? Logical box or log box. And then after that we just want to say false, copy ID 0, and let's check for overlaps. So let's just make sure we wrote it correctly before we do any visualization. Yep, and let's just quickly run in batch mode just to make sure we haven't got any overlaps somehow. So I just pipe this to less, just so I can scroll through easily. So see, we've placed our G4 orb, our fizz orb, as we gave it the name, and our fizz box. And while we're at it, let's just place it. So you see it starts in the physical world and then goes into the fizz orb. And that's because since the sphere perfectly fits inside the cube, then once it enters the cube, it's automatically at the orb, since at that point that's where it touches the boundary of the cube and the orb. So that's why we only see the orb and we don't see fizz box being placed there. So I'll just press Q to get out of less. So if you ever want to visualize anything, remember you can just, if you want to just slowly go through the output of a Geant4 simulation, you can just pipe it to less like that. So our code we wrote there seems to be okay. So let's just copy the visualization we already wrote. So let's just call this orb attribute just to set it apart. So let's just replace all these, and let's put this as, let's make it white, so just so it's slightly easier to see. So orb attributes, then the logical volume we want to see. So all we've done is we've passed the orb box to this visual attribute, which we just copied based on the fizz box attribute. So all we did was make it white, and at the moment we've got it as a wireframe. So if we just recompile, does that okay? So edep sim, let's just look at it. So in this case, it seems like Geant4's changed since last time I visualized a sphere. So in the olden days, it was actually, all you'd see, if you're lucky, was just a circle, or sometimes there was nothing, but it looks like now they've actually got it visualizing out of the box. But just in case, it still applies for a cylinder. Let's just check a cylinder. Let's learn together in real time. So I'm now going to use the tubs function. So let's include the G4 tubs. So is it G4 tubs or G4 tub? Yep, tubs. So we'll include that header as well, so we can use that code. And I'm just going to quickly change the G4 orb over to a G4 cylinder. So for simplicity, let's just keep the name the same, but we're just going to change this to G4 tubs and have G4 tubs there. And let's look at what this function expects. So it expects a name, as all the solids expect its first thing. Then it expects the minimum radius, then the maximum radius. So let's just change that to 0. So let's go 0 for that's minimum radius, then maximum radius. So that should be good for our size there. And then the next one is PDZ, which is our half length in Z. So let's just make that also equal to the radius. And while we're going this deep into the rabbit hole, let's just make a variable called radius for the time. Since we've done this much radius at this point, let's just try to be a bit nice. So let's just replace this with radius. And you saw I divided by 2 there, so it's an actual radius now instead of height. So what else does it expect? So we've given it a name, we've given it minimum radius, maximum radius of like this, the cylinder here. So height, and then we just give it the minimum phi and maximum phi, so the starting angle and the ending angle. So we can just enter here 0 times deg, and then 360 times deg. So this cylinder will go from 0 to 360 degrees, so a full cylinder, and its minimum radius is 0, so it's a full cylinder. It's not an open cylinder. Its size is equal to our box that we placed before, and its height is equal to twice the box, and that's equal to radius, so that should be good. Let's just check and compile, and possibly we made an error. Okay, nothing obvious, maybe we've got an overlap, so let's run edepsim. Well, I'll be. So in the previous version of Geant4, you always had like either nothing or just an outline being shown. But alright, so Geant4 has actually made wireframe usable for spheres and cylinders. So forget that last tangent, but you know, if you're interested, you can now place a sphere or a cylinder. But actually, while we're placing multiple volumes, let's just go back to this orb for convenience. Oh, wait, sorry. Yeah, let's go back to this orb, comment that, and we're just placing this with the radius. So let's say we want to place this. So let's say, remember, we're placing this sphere inside, and we've changed it from a cylinder, it's now a sphere because we're using G4 orb. So before we were just placing in the center of this box, and the radius was equal to the box's length. So let's say we accidentally had the mother volume set to the logical world. So let's just change that. And if we try to compile that, again, code's fine. But if we actually run it, and visually, and if we look at it, it looks okay. But once we actually see the output, we see that G4 orb has an overlap where it's placed inside this previously placed volume, and in this case it's being placed in the G4 Viz box, Fizz box it should be. So yeah, Fizz box here. And whereas before in the last video or so, we placed our Fizz box outside of the world volume, and in this case we placed the sphere inside. We used its mother volume as the world, and then we placed it fully inside of the box. So if you just visualize this and you didn't look at this output, you would think, oh, yep, great, I've got my geometries all sorted out. But if you actually started running this, then you might actually come into problems because your geometry has got overlaps. So just wanted to quickly point out that even though just because something looks okay when you visualize it doesn't mean it's actually correct. So always make sure you check this overlap checker here, and that's that. And we learned together that you don't need to use anything but wireframe for spheres and cylinders.